All right, this week's homework is going to be a lot of slope and proportional relationships, some functions, and then a little bit of non-proportional, since that is our newest topic that we'll be discussing this week. Again, we have our bell works, and then just to start us off, this is going to refer back to our notes, and as I go throughout, me in class, Mr. Campbell in class, we're going to be talking about slope in a lot of different, using a lot of different words. So our first word obviously is slope, and then our first type that we talked about mostly with our graph is rise over run. That is one. Another one that we've talked about is rate of change, which is our miles per hour. That's an example. We have a unit rate, which could be something along the lines of maybe eggs per carton. Let's think. This one also is referring to graphs. We have M, which on the formula chart is the letter that represents slope. I had some students say M for mountain, so if that helps you remember that M is a type of slope. And then we have K, which is only used when the relationship is proportional. So this y, that is when the y equals kx. That k is our constant of proportionality, which is technically the slope of the line. So there's that. And moving on to proportional relationships, we have this says if y varies directly with x and y equals 60 and x equals 15, what is the value of x when y equals 80? So before I start writing things down, I'd like to talk about this phrase right here. This is kind of a green light to proportions. There's many ways that we could go about solving this, so I want to show you in two ways, but when you see this, if y varies directly with x, it's referring to the y equals kx, direct variation formula. So we can solve this first by using k. We could say y equals 60, we don't know k, and x equals 15, and we can go ahead and solve for this by dividing both sides by 15. That will become 1, and we'll just be left with k equals k equals 4. And then we can use this to solve for, we need to know x when y equals 80. So if we have y equals, we now have our direct variation formula would be written y equals 4x. And we can then substitute here with y equals 4. Oh, sorry. We do know y. So y equals 80. 80 equals 4 times x. So again, we're trying to solve for x, so we'll divide both sides by 4. And then we'll be left with x equals 80 divided by 4. Go ahead and take a minute. With x equals 20. So there's one way we could solve it. And so I just wanted to show you the other way, is when we have y divided by x. So we have y is 60, x is 15, equals, because of that proportion, we can say when y is 80, what is x? When y is 80, what is x? So in this case, we'll want to cross multiply 80 times 15. And that will give us 1200. And then that will equal 60x. Divide both sides by 60. And we'll left be x equals 20. So you can see here, we get the same answer here and here. It's just whatever way works for your brain, both ways. This is the butterfly method. But again, you need to see this right here before you set up your proportions. All right. So here we have a table, XY table. Does this table represent a function? So that is our first question we're being asked. So when we're talking about functions, we're talking about inputs and outputs. So these are our inputs and our outputs. So from here, we're going to want to look at if all of our inputs are different. So in this case, we have a 2 here and we have a 2 here. But when we put a 2 into this function machine, we're getting a 36. So as long as we have a 36 here, we are okay, and we can still say this is a function. So from here, we're going to want to figure, is this table proportional? So proportionality is talking about, that's when our y equals kx comes in, and that is going to come from y divided by x. So if we take 36 and divide it by 2, we get, so 36 divided by 2 is 36 divided by 2 is 18. 90 divided by 5 is 90 divided by 5. 90 is also 18. 216 216 divided by 6. So it looks like we have a 36 here. And then we're going to have an 18 again here. So right here we have a different one. So this one is not proportional. So you have to make sure to check every single x. And if it's not proportional, so if proportional, write the equation, but not applicable in this situation. All right. So now we're being asked to graph the points and find the slope. So again, right here on this side, we have our negative x, we have our positive x, we have our positive y, and we have our negative y. And so I'm just going to label some of these points. 1, 2, 3, negative 1, negative 2, negative 3. This would be 1, 2, 3. And right here would be negative 1, negative 2, negative 3, just to show you guys. So when we're plotting points, always start from the origin. So we have negative 1, 2, 3, 4, negative 1, 2. We have 0, 0. This is the origin. And we have 1, 2, 3, 4, 2. So we have these points. I'm going to try and draw a line. Almost straight. So it says graph the points and find the slope. So then the easiest thing on a graph is to use a rise over run. So right here we have rising 1, 2. and we're running 1, 2, 3, 4. So this right here is going to simplify to 1/2. And so from there, you're going to want to determine if it is proportional or not. So remembering what describes a proportional graph. Okay, which of the following has a constant rate of change? So, constant rate of change, this was on our last test. You're going to want to take all of your y's and divide them by x, and you have to get the same number for every single one of them. So, if, for example, like if this one here and this one here are the same, but this one is different, then it would not be proportional. If this one is the same, this one is the same, and this one is the same, then it would be proportional. But they all the y divided by x's have to be equal. So go ahead and take that and with a calculator or in your head, whatever floats your boat, and then you're going to want to circle the one that is correct. All right, it says find the slope of each and then circle the slope that is the largest. So when we're given 2 points, we're going to want to use, since these ones are really big, we're going to want to refer back to our slope formula. It says slope equals m equals y2 minus y1 all over x2 minus x1. So what I like to do right off the bat is label my coordinates like this, x2, y2. And I even like to circle the numbers that are associated with it. So from there, I like to look at so in every single equation, there's this line in the middle with 2 subtraction signs. So just so I don't even forget them right from the beginning, I like to draw my line and my subtraction sign. And then from there, I like to fill in the blanks. So we have y2, 17, minus y1, which is negative 12. And then bottom we have x2, which is 9, minus x1 is negative 6. So then on your calculator, you can put that directly in and then make sure you leave it as an improper fraction. And then over here, we again draw our line, subtraction sign, and then x1, y1, x2, y2. So from here, using negative 1 minus 19 and negative 10 minus 1. So you'll be able to get both answers, and then again, remember that it's saying to circle the slope that is the largest, so don't forget that part. All right, here we go. The charge varies directly with the hours. Fill in the blanks to complete the table. So when it says it varies directly, the charge varies directly with the hours, this is talking about proportionality. So it's referring to our y equals kx, where k is the constant of proportionality. So our time is always going to be on our x-axis, and money, for the most part, is going to be on our y-axis. So we have this here. So there's many ways that we could go about solving this. We could set up a proportion to solve for these missing spots. We could divide our y by our x and see what our k is, and I think that's what I'm going to do. So y equals kx. So I'm going to use this x and y. So 60 equals k times 3. And I'm going to divide both sides by 3 to solve for my k. So 60 divided by 3 is going to leave me with a k of 20. So since it's proportional, I know that I'm going to be So to get from 3 to 20, I had to multiply by 20. Or 3 to 60, I would multiply by 20. So that means going across here, I'm going to have to multiply this by 20, multiply this by 20. So 6 times 20. So if I'm missing my y, again, I can use my formula here. So since I'm missing the y, I can have y equals 6, which is my 20, which is my k right here. And then I have my 6, which is my x. And then we'll be left with what number I can put there. And then over here on this one, I'm going to set up a proportion just to show that the other way of solving it. So I could do 180. So if it's charge over hour, so we have 180 over 9, and that equals charge to 20 over hour, which we don't know. So again, here we can cross multiply 9 times 220, which will give us 1,980 equals 180 times x. So that leaves us with a cross multiply and divide. And that leaves us with a clean number. So just go ahead and you can figure both of those out using the cross multiply and divide, whichever way is easiest for you. So this says to draw a graph of proportional and non-proportional relationships. So maybe you can take this one as proportional and this one as non. So remembering that proportional relationships are straight lines through the origin. And non-proportional relationships, there's a little more wiggle room of what you can provide, since there's a wider range of things that you could do. All right, here we go. We have every 3.5 hours a machine produces 140 basketballs. What is the unit rate of this proportional relationship? So we know that when we're have a proportional relationship, we have our y equals kx, this being the constant of proportionality. So x is going to always have to be this is our x because it's time. And then that leaves this 140 to be our y. So when we substitute them into our formula, we have 140 basketballs equals k, which we're solving for, times 3.5 hours. So again, we have to divide both sides by 3.5, and that will leave us with our unit rate, which is, remember, another word. This is another word for slope. Just like k is another word for slope. But it's only when the relationship is proportional. So k is only for when it's proportional. So from there, you'll be able to solve this. We'll cancel, and moving on. All All right, last days of homework. We have bell work, and this one says to find the slope of the line, and then it has a question. It says, is it proportional? So first, slope, which is rise over run, rate of change, and so forth. I just like to use rise over run when I'm referring to a graph. So we're going to have to find our pretty points. Remembering that pretty points are intersections of these. So it's, maybe I'll use a different color. So it's this intersection right here of these pre-made horizontal and pre-made vertical lines, and they have to intersect on, and those where those intersect right there. Sometimes it's hard with these graphs because they're not the best quality, but for the most part, like if you look at this one right here, if I tried to draw a pretty point, I guess there's only one more, but like this one right here, it has that intersection there, and it also has that intersection there right on the blue line that's being graphed. So from there, we can use rise over run to find our slope. So our rise, I'll go ahead and use these same colors, rise and run, rise 1. So from there, make sure you get your answer, rise over run, and then is it proportional? So again, if it's proportional, that means that it needs to be, there's 2 key indicators for proportional graphs. So this isn't talking about functions because this one is a function. It passes the vertical line test, whereas we can see it right here. This vertical line test, it passes. So make sure, here, I'll write it down here. Proportional, yes or no. So right here we have time in months and savings in dollars. Does this table represent a function? Is this table proportional? And if proportional, write the equation. So again, going to representing a function, we're going to look at our x values. So it looks like we're in the clear on x values. Now we have to check our proportions. So remember, time x, savings y. So you have to check all the y divided by x. And then if it's proportional, again, you'll be solving for a k, and then your equation is going to look like y equals kx, and then you're going to substitute in whatever you get if it is proportional. So write the location of each of the pretty points, then find the rate of change. So the pretty points have already been given to you. So on here, remembering that this is negative x and this is negative y. So again, they're going by ones, 1, negative 1. So finding the location of these pretty points. So once we find the location, we have always starting from the origin, negative 1, 2, 3, 4, negative 4, negative 1, 2, 3, 4, negative 4, negative 4. So that's what we're talking about. Location is right here. And then finding the other one, finding this location. So then you'll have another location of this right here. And then you can find the slope with the graph, or the m equals y2 minus y1 all over x2 minus x1. So whatever you feel whatever floats your boat, whatever makes you happy. But you're happy that you're done. Your homework is done for this week, and hopefully this is